Hey everybody, KC0VI Tom. We're out here number one along with Mr. Duke. What do you say? Hey, what do you think? Huh? You looking for treats? We have new treats. It's a chicken flavor, and he won't eat any of his older treats until he gets all the chicken ones done. As you said, we're out here in the number one greenhouse. As you can tell, the plants are looking real good. Did some deadheading. I cleaned up some of the dead leaves on here. Got all the big ones off. Didn't really notice these small ones, so I was all done. I was like, oh, okay, I gotta go back through and do it some more. And a lot of them are just, with more sunshine we're getting, the smaller leaves are dying out. Today, as you can tell, it's going to be nice and sunny. We're having highs in the upper 40s. A little thaw here in February before the holiday week, and coming up we got Valentine's Day. What's that all about, I wonder? Along with President's Day on Monday. So we're going to do a little technical video here on using a volt ohm meter or digital voltmeter, or if you remember, for a short time there are also AVMs out there, analog voltmeter. Talk about that later. Just something to break up the monotony out here during the winter time. Smoke, you're not supposed to be out here. No, Mr. Cat. It's not the world's largest cat box. So what we're going to do, we're going to come over here. Got a couple voltmeters and a couple items we're going to measure. This is an analog VOM, it was originally called. When they started coming out with digital voltmeters, a lot of the manufacturers are starting to call these AVMs. You know, just a fancy word because we have DVMs, so we must have AVMs. This was probably the first meter I've purchased. Between 6th and 7th grade that summer, I mowed a lot of yards in my neighborhood, and I was not going after the voltmeter. I was actually going for Daisy had a BB gun that you would hold 200 BBs, and you put a canister of R12 in the bottom of it, and when you pulled the trigger, as long as you had BBs and R12, it was full auto. Oh man, I wanted one of those so bad I could rain terror on all the birds in my neighborhood. Had all the money in this envelope, rode my bicycle into the local coast-to-coast store. Yeah, that's a hardware store you don't hear anymore. Flopped it down on the counter and said, I want this, this, and this, and the salesman looked at me and said, no, you have to have your dad come in and I'll sell it to him. I was heartbroken. A couple days later, helping Dad on something around the house, we had to get some parts, so we went back coast to coast, and he got what he needed. I dragged him over to the gun counter and says, Dad, here, I want this, this, and this, and here's my money. Now, all my money I had was in this old envelope, and it was pretty well torn up by then. It was a bunch of singles, a couple fives, a handful of change. And it was duct tape and scotch tape and masking tape together. Dad looked at the BB gun, looked up at the salesman, looked at me and says, are you effing kidding me? I was heartbroken. I mean, you crushed a kid, boy. Yeah. But the following week, we got the sales fire from Radio Shack, and this meter is going on sale. This is a nice little meter to starting out. It'll do DC volts, DC current up to a certain point, ohms, and AC volts up to a certain point. As you set what you're going to measure down here, get down there right deal, then the needle is going to deflect up. You have to remember what range setting you're on. If you're on the 10 volt scale, you want to use the bottom one. If you're on the 125 volt scale, use the third one up. Now this little mirror, if you ever find a meter at a garage sale or on a pawn shop, an analog one, if it has this reflective mirror in the back, well, all mirrors are reflective, but that's real important. That will cut down parallax, they call it, which will increase the accuracy as you read the meter. Get here closer, because what you want to do is you line up the needle over its reflection. If you're off to the side, you're going to see the reflection. That means you're not straight on. You're going to have a funny error in your reading. So that's real important that you have a meter with a mirror on it. A couple years after I had this one, the parents realized, hey, this guy's pretty good at electronics. So now I was using this to building kits, Radio Shack kits and other stuff, fixing stuff around the house. And for Christmas, probably my 9th or 10th grade year, I got the higher end analog VOM from Radio Shack. It wasn't the top of the line, it was the next one down, because if I remember right, the top of the line was out of stock. And they didn't want to give me a range check, so they just got me the next one down, which was fine. And I used that thing quite a bit, and until the parents had this furnace in the basement. It was in the corner. There's probably 3 feet on the side of the furnace to the brick wall, and it had one of those electronic air filters in it. And the idea is you had a series of plate they called a cell, and it took 120 volts from the wall upped it up to about 6,000 or 7,000 volts, ran it through a bridge rectifier, had a couple capacitors, and you had 5,000 volts DC. Now the plates were negatively charged, and above those plates on that cell there was some real fine wire, almost like piano wire. And what you would do is put the positive lead there from the power supply, the negative on the plates, and the idea is, unlike charges attract, like charges repel. So as the dust was coming through the airstream, you would go across those fine wires, get positively charged. Then when it got down to the plates, it adhered to the plate. Then once a month, you'd pull those cells out, shut it off, pull the cells out, put it in your dishwasher, run them through a water cycle, put them back into the air cleaner, but do not turn on the power, and let it run for like a day to dry those plates off, then turn it on. Well, it stopped working. Dad was kind of concerned about it, so we went down there one Saturday morning, and I measured 120 volts coming into the circuit boards. Okay, so that's got there. And I knew enough not to try to measure the 5,000 volts DC on this old meter, or this analog meter, because I don't have the proper leads. These leads here, I believe these are 200 volts, kind of low end. It's a low end meter. And, so I'm in there looking, and I noticed one of the electrolytic capacitors is kind of bulges. That's the problem, Dad. And we unplugged it, shut power off to the unit, and we're sitting there talking a little bit. There's a couple of resistors in there I thought were part of a bleed-off circuit to bleed off those capacitors. So I took that old meter, set it on ohms, put the leads together, made sure I had 0 ohm, put it across the electrolytic, and I remember the little coil here in the meter movement turned bright white. Then I felt the wall hit my back, and I slid down to my butt on the ground. My dad looking down at me and says, "You okay?" I go, "Yeah, we got high voltage." What was happening, that capacitor wasn't quite dead. It held a fairly decent charge. The other one held a lot of charge. So what we ended up doing is just getting the numbers off the side, the value off the side of the capacitor, went back to Radio Shack. Now these were high voltage caps. They wouldn't have them in stock, but they had a ability to order parts like that, specialty parts. So we got those in a week later. I put it in and fixed the air cleaner at the cost of a nice VOM. Anyway, so when you have a meter, a couple things you want to look at. See if we can get into this one close. Up here it says Cat 3, 600 volts. Then over here on one of the leads, on this one, it says Cat 3, 1,000 volts. These are rated in different, is that a 3 or a 2? And 3. There's ratings on this for your protection. And that's one thing you always want to do. Let's get a little closer look at the DVMs, and we'll talk about how to measure stuff. Okay, when you get your meter, always try to store your meter leads, wrap it gently around it. A lot of meters have little holsters to hold the probes in when you're not using them. What I was told by an instructor I had in high school electronics class is take your 2 fingers and your thumb and put it on the meter leads like this and pull them, and that's going to do 2 things for you. A, it's going to untangle your meter leads. If you ever out there, any of you guys, smart guys out there, come up with a way to make a wireless probe for a meter, you'd make a fortune. Patent it, and you'll make a fortune. The other thing you're doing is as you're running your fingers across the insulation, it'll tell you if you have any scrapes, burns, cuts, cracks in the wire, and we don't want that. This is our protection. Like I said, these are, what they saw, 20 amps at 1,000 volts max, Cat 3. That's an industrial standard for what this meter will protect you from. And again, this is a little Fluke 12B. And again, take your leads and run them through, untangle, make sure there's no defects in the lead. And we'll take a little closer look on how each one of these operate. Then we're going to talk about a few other things. This is a Fluke 87 Mark IV. Yes, they did make a Mark IV. It wasn't too long in production. They had some problems with it. But on your meter leads, I got the camera between me and the meter. This will be interesting. When you're using the leads, always make sure you have your fingers behind these finger guards. Obvious reasons. If you get like this and try to measure something, somebody in the room is going to have a good laugh. Trust me. And we'll put the alligator clips on. The alligator clips used to have threads on the inside and threads into the probe, but they cheapen up the process here. So the first thing we're going to do, you're going to set this. This will do volts, AC volts, millivolts AC, DC volts, millivolts DC, ohms. It'll do checking capacitors and diodes. If you have the proper probe, it'll do temperature. Then it will do some current, low current. I believe this has something like a 1 amp on this side and 10 amps on this side, but I would not recommend that because it's real easy to blow the fuse when you're. So we'll go over here. We'll do ohms, and I do have a couple small resistors. I don't have very large physical large resistors. This is a 1000 ohm resistor, brown, black, red. If you don't know what I'm talking about there, we'll have to do a video on the color code. And first thing you want to do is on your meters is you want to short out the meter leads and make sure it's reading close to 0, 0. This is about 1 ohm, so I'm assuming my battery might be getting low. So probably should change out that battery here real soon. When I'm not using the meters for a long time, if I know I'm not going to need it, I will a lot of times pull the battery out. Okay, so now when we put the lead on the resistor, we're actually reading 0.99. That's 990 ohms, just under 1K. So this component's good. Then I think I have like a 10 ohm over here. Brown, nope, yeah, brown, black, black. That's roughly 10 point. Now these are 5% resistors, or yeah. So they're 8 watt resistors. So that's how you measure ohms. Now, what you want to make sure you don't want to have your fingers on here, because as you can see on my body, I got roughly 1.5 mega ohms between my 2 fingers through my body. You don't want to do that when you're measuring something, because that'll throw off your readings. Capacitors, again, when you pick up a capacitor, you want to be extremely careful. These will hold a charge for a very long time. This one, I've already discharged this off camera. Now, you do not want to take a screwdriver and put it like that. That can damage the capacitor. What you want to do is take like a 1K ohm resistor and put it across the deal to dissipate that energy that is being stored into. Take a 1K ohm resistor, solder it to a couple of clip leads, and just keep in your tool bag for that purpose. So we got it on microfarads for capacitor checking. We'll hook this up, and this is reading. It worked during rehearsal. There we go. 1.2 amfarad, which is, this is 1,000 microfarads. They do a power 10. So yeah, this capacitor is correct. A lot of times what I'll do is I'll reverse the leads just to verify that. Yeah, I'm touching, that's why. That it's working good. We'll grab a smaller one. The 87 doesn't read very large capacitance. That's why I have the 12. This was part of a meter kit when I was teaching the students would buy. And the lead fell out. And what we got here? 48 microfarads, and this is a 47 microfarad component. So that's pretty much how you read capacitors. Very quick and easy. Okay, we're going to do some DC measurements. We got it set for DC volts. This is a 9-volt battery, and this is a 1.5 AA cell. This is just one cell. This is 9 cells or 8 cells, whatever it is, to get to the 9 volt. Just technicality there. If you would measure our DC volts, slide this up, we can see it on camera. As you can see why. And you go and measure it, you're not really putting a load on the battery. We're reading, it's reversed because I got the leads reversed. It's measuring 9.5. Wow, I got a great battery. In reality, what you should do is take a resistor and I used to have one of these with clip leads soldered on because I used to always check it. If you buy a commercial available battery checker, they'll actually have a small resistor. This is the 1K ohm resistor. What you want to do is put a little load on the battery to make sure that it can handle the load, so then we know it's good or bad. Now we put here, as you can see, we dropped down from our 9.5 to 9. Just, less than a half a volt. That's a good battery. On the 1.5 volt batteries, if it drops down to a 0.2 from 1.5, it's still a good battery. That's a good way to check it. Like I said, commercially available battery checkers will have a small resistor made internally. Just a little tip. You can sit here all day and measure batteries, and yeah, they're all good. When you go to use them, they're not good, because when you put a load on them, that's how you can tell if it's a good battery or a weak one. Same thing if you do a generator. If you have a generator at home for power outages, you should at least run it once a month. And again, don't just let it sit there and idle for an hour. Fire it up, let it run for like 10 minutes, plug a light or a fan or something on there for the next 45 minutes, 50 minutes, unplug it, then let it idle to cool down for 5-10 minutes, then shut it off. Okay, I just grabbed a power cord from a device, spare cord. The meter is set for volts AC. Now it's set for volts AC. And again, you want to be real careful because one lead is hot, the other lead is the neutral, and the bottom one is always ground. So in AC, there's no real true polarity, so you want to stick one in, the other one in. As you can see, we're reading 120.6 volts. Now you would not want to put the resistor across there because it'll pop that sucker. AC is, you can measure like so. If it doesn't stay in, you got to use your fingers. Again, remember to stay behind the finger guards, and that'll protect you. So that's a real important thing you can do. Another thing, on some meters, we'll get a reading, we have a min-max. Knock the lead out. And say you have a problem where your lights flicker once in a while. If you hit the min-max, what that's going to do, it's going to record the minimum voltage, the maximum voltage, and you'll hear it beep a little bit. That's when it's a new one, and we'll let it run here for a little more time, and beep, beep. Then if you hit the min-max button there, the minimum was 120.58, the average is 0.7, and we had a high of 8.2, and around here it's not too bad, but I've been in office buildings where computers were rebooting. What we found out that there were so many computers on the circuit that when the local laser printer would kick on, this 120 volts would drop down to about 100 volts, and most computers, power supplies will reboot when they get to the below, at the 100 volt line. Now, when you go to measure current, what you have to do, you're over here either on AC or DC current. This is very small current. I think this side is less than 1 amp, and this side here, no, here's the current. A lot of times on these current meters, you got to move the lead from your volt ohm side and put it over to the current side. This one location here is 1 amp. This one here is 10 amps. What you need to do is cut the wire and put your probes, in the cut so the meter is in series with the load. So the current is going through from the wire into the red lead, through the meter, out of the black lead, back to the power supply. Kind of cumbersome, hard to do. If you have a power supply, say on your radio or running something, you suspect it's not putting out enough current, what you can do is set this to volts. This is going to freak out. We'll pull that out. Good way to blow the fuse inside it by measuring voltage when it's set up for current. Is put this across the output of the power supply, then run that load. If your voltage drops, that means your power supply is either damaged or it's not able to put out the current needed to run that device. Another thing, we just ran into this on our digi-repeater in the area. The electrolytic capacitor inside failed or was in the process of failing, and out of that 13 volts we had feeding the radio and the digi-repeater, we had almost 2 volts of AC ripple on top, and that was causing the VCO in the radio to drift off around on frequency. Also the modulation, it was really messing up the modulation. If you need to measure high current, or current, thing to do is buy one of these clamp-ons. This one here will do AC and DC current. You just, thing is you have to put one lead or one wire through the jaws, set this to millivolts DC, and it will read it. If you put, because what happens as AC is on these wires and current is flowing, you get magnetic lines of force around the wires. If you don't believe me, have something like this run and take a small compass and come near the wire. It'll swing the compass off. So you just, and if the wires are good like this, you try to measure them, it's going to cancel out the reading. You get an oddball reading. So you just want one wire in the jaws. If you measure like that, I don't know what you're going to get. So this clamp here, again, will do AC and DC. The most common ones you see is AC only, and these just plug right into the meter, and the instructions on these tell you to set it to millivolts DC, because what the Hall effect sensor in this will do is take those lines of force, convert it to a small current, and put it in here. Now, if you got to measure less than an amp, the trick is take that wire and coil this up for like 10 turns if you got enough room. Put this through that coil, then whatever you read on the meter, divide it by 10. That's a nice, easy way. You don't have to cut into it. You can read small amount of current and yet not have to damage any wiring. If the wire is long enough, of course. We use that on thermostats to set the heat anticipator. We have students would make a small coil, 10-turn coil, take the thermostat off, put this on, the coil on, measure the current when the unit was running, the furnace was running, and that's how you set the heat anticipator. Now on the Fluke 12B, this is a little different meter. You got off, volts, then your special functions. You'd select the volts, then up here you would select either AC, DC volts. Then if you're over here on the special functions, we'll go through and give you ohms, continuity, which I tell you don't use, and diodes. Capacitance checking here. It does have a min-max range to check stuff, you know, for minimum, maximum voltage. These are automatically ranging meters, which means they start at the highest range level and work down till they get a stable reading. The old analogs, you had to start unknown voltage. You want to start at the highest setting, then slowly work your way down till you got an accurate reading. Very important to protect the meter. Now, most of you guys have seen something like this. This is a nice little handy checker for wiring. You got 3 lights on the bottom, and depending on what light appears, you should have the 2 yellow lights on this side. You got a good circuit. If for some reason you're hot neutral reverse or open neutral, they'll be up here, and that's why it's a good thing to have to check any wiring if you're working on installing new wiring or replacing a plug, or if you believe you have a problem with the wiring. It's getting a little warm out here. We're going to cut this little, brought done anyway. There's one item that I'll tell you do not use. You'll see these out in the market. There was a class action lawsuit on one of the manufacturers of this device due to the fact that they give off false readings and people get hurt and killed. It's one of these little proximity checker. The idea, this has no battery, and I found this in a box of stuff I inherited from my dad, and it's just, I'm going through that stuff now, and I haven't pitched this yet, but I'm throwing this away. What this is, when you get near electrical wire, the idea is you push this button, and if it's energized, the light will flash, and you hear a little, but it's not always accurate. It just tells you that, yeah, there's something there, and sometimes there's something there, but it doesn't read it. So again, do not use these. There are some meters that have this built in. Field piece, HS33 was one, and 35 was one we used at the tech school I was teaching at. I would tell the students, don't use that. That's dangerous. Why is it in there? Because it's a cheap, easy accessory. Some people think it's great. The reason I'm telling you not to use this, when I was working with control data, when I got out of tech school, instead of getting laid off one winter, they asked us if we want to help demolish and help remodel one section of the plant. They were cutting down one line and bringing over another line. Sure, you still get paid and get to smash stuff? Hell yeah. And the power to the production floor was on overhead bus beams. And it was a metal encased beam. They were probably 4 to 6 inches tall, a couple inches wide. And they were, you could mate them together on the end so that you could run them as long as you wanted to. And inside this metal case were 4 bus bars for leg 1, leg 2, leg 3 in ground, or leg 1 neutral in ground. Let's see. No, leg 1, leg 2 neutral in ground, depending on what type of power you need. Because we were making computer equipment for all over the world. So some were 3-phase, some were single phase. And it's been so long since I'd worked on this. But what had happened, the electrician, the master electrician on the company that was doing the remodeling we were helping out with, we had pulled everything out of the production area, and he had a ladder out, and he had one of these long screwdrivers, about an 8 to 10 inch shank on it, and you slide the screwdriver in through a special hole between the bus bars. You turn that a quarter turn, and it released it from the hanger. Then we could take it down. You release one, go down, and release the couple other ones, and you could take it down. Well, he ran off, shut off what he thought was the breaker for that line, came back in, oh, nothing, line's dead. Stuck that screwdriver in there, and he clicked that quarter turn. When you're pulling it out, he actually lifted up and shorted out that screwdriver shank between leg 1 and leg 2 on a 3-phase system. There was 4 of us in the room with them, me and 3 other guys. I just heard a bang when I turned around. I saw him falling off this 10-foot ladder, hit the ground. The other 2 guys, they saw everything, and they just said it was a flash of white light like he's ascending. And we got over there. I had one of the guys who was quick, ran and got first aid. They came, And he was groggy when I got to him and the other guy got to him. And we told him, hold still, hold still. He says, oh, I didn't get shocked. And he says, no, you didn't get shocked, but you fell from 10 feet up in the air. And, you know, the first aid came in and we kind of backed off, let them do their job. They had emergency services coming. And one of the guys I was working with, he found the plastic handle, and that 10-inch shank was down to maybe 2 inches and it was gone. I mean, you could see where it was melted. And we showed it to the first aid team, and they started noticing on all his clothes there were little burn marks. It vaporized that shank. You know, then they were worried about his eyes and his face. And what had happened, he turned it and it was turned away to talk to us. And that's when he slipped. So he had a little burn on his ears, but nothing in his eyes or in his face. So he's lucky there. Again, don't use these. If you want to be my friend, throw them away. Don't even buy them. If you don't want to be my friend, show me how good these are, and I'll never talk to you again. I'll bring flowers to your site. Well, that's kind of in a nutshell. Again, there's a lot of different style of meters out there, a lot of different accessories or different functions they can do. I have one meter around here. It's more of an automotive meter, and it has a lot of stuff for cars. I mean, you got temperature probes. I believe there's a setting so you can hook up a vacuum module to measure the vacuum on the manifold. It's depending on what you are going to use it for. Now, there's nothing wrong with these old Radio Shack meters. You're not making money off. You're not earning your living. If I was an electrician, yeah, then I'd buy a Fluke. If I was working on cars, then I'd buy a good Snap-on meter. It was actually made by somebody else. They just put their name on it, but even though they laid out the specs. So find out what you really need. And meters are getting fairly inexpensive, new ones, and even on the used market. I have quite a few of them. I got one downstairs on a bench I was going to grab, but there's too much stuff in the way to get the power cord off. But I have quite a few. Well, we got 3 here, plus there's one in the camper, plus there's one downstairs, and there's also one in the scan toolbox. So you got 5 or 6 meters I got floating around the house here. Again, they're handy to have when you're working on stuff. Kind of decide what I'm going to be working on, what special functions I need. Now the 12, this capacitor range is higher than the 87 due to the fact the 87 was mainly for circuit boards. The 12 is actually was set up for more of the HVAC industry, electrical. With electric motors, we have that large capacitor to help start and help run the electric motor. That's why that has a higher range. So, any questions? Put them down in the comments. Sure, nobody's going to comment, and we'll go from there. Again, we'll throw out a couple more of these tech shows. Get through this midwinter doldrums, as I call it. And Mr. Duke, he has an appointment with Canine Campus coming up. You're going to get a big major haircut. We were running around doing some errands yesterday, and he got a little too hot in the car and got sick. He felt bad, but you know, it happens. I'm not used to a dog with so much hair. It's really, he looks fat, but a lot of that's hair. Duke, Mr. Duke, yes, that plant's attacking you. On that, everybody, 7-3, thanks for watching.
Be sure to tell your friends, neighbors, other hams. Subscribe, hit that bell to get notification when new videos come up. Add comments below. 7-3, everybody.